so the last week you've been working on geometric sequence, which is similar to arithmetic, but there's a few differences. So we're going to do a quick review today, and then we are going to go through some example problems, and then just like last week, the remainder of the questions will be a quiz grade for you. So starting with the definition of geometric sequence. So a geometric sequence is a sequence of numbers in which the ratio, and we call the ratio in this case R, okay, remember that, sorry, the sunlight behind me is messing up the paper a little bit, there we go, remains constant. So instead of a constant difference, in this case we have a constant ratio, okay, and now the common ratio, the definition of that, it is found by dividing each term by its previous term, and it's important to do the term by the previous term in order to find the ratio, otherwise you're not going to have the correct ratio. Okay, so just remember this is all review from what we've been doing. So when we're looking to see if something is a geometric sequence, the first thing we need to do is find out if it has a common ratio, meaning each of the terms has the same ratio. So to do that, we take a term and we divide it by the previous term. Okay, so in this case, 10 divided by 2 is a ratio of 5. And then 50 divided by 10 is also a ratio of 5. And then 250 divided by 50 is also a ratio of 5. So yes, this does have a common ratio, and the common ratio is 5. Okay, so down here, we're going to do the same thing. All right, we're going to divide 18 divided by 3. That gives us a ratio of 6. And then 24 divided by 18 gives us a ratio of 1.3. And 30 divided by 24 is a ratio of 1.25. So this does not have a common ratio among the terms. So no, this is not a geometric sequence. Okay, and then we go to number 5, where we're going to do negative 40 divided by 80 gives us a ratio of negative 1/2. 20 divided by negative 40 is also a ratio of negative 1/2. And negative 10 divided by 20 is also a ratio of negative 1/2. So yes, this is a geometric sequence, and the ratio here is negative 1/2. Okay. All right, so when we finish this up for your quiz, you're going to complete 2, 4, and 6 on your own, doing the same process, just dividing each term by its previous term. Okay, 15 divided by 45, 45 divided by 135, and so on. All right, the second part to this is whether or not you can continue the sequence. Okay, so once you know how to tell if it is a geometric sequence or not, we have to be able to continue that sequence. So here we have negative 21 divided by 7. That is a ratio of negative 3. Okay, and then 63 divided by negative 21 is also a ratio of negative 3. Okay, so that is our ratio here. So that means that we're going to need to multiply this number by negative 3 each time. So 63 times negative 3 is negative 189, and negative 189 times negative 3 is a positive 567, and 567 times negative 3 is a negative 1701. Okay, so it's the same process. We just have to find the ratio, and then we are multiplying each term by that ratio. So we'll try number 9 as well. So 4 divided by 8 is a ratio of 1/2. 2 divided by 4 is a ratio of 1/2. So we're going to multiply each of these terms by 1/2. So 2 times 1/2 is 1. 1 times 1/2 is 1/2. And 1/2 times 1/2 is 1/4. Okay, and you may get those in decimal terms, so that would be 0.5 or 0.25. Okay, so those are your terms there. And so you're going to continue the same pattern. You're going to find the ratio and then multiply each term by the ratio for 8 and 10. So you'll complete that on your own. All right, and then let's go ahead and talk about what if we need to find a term and we don't want to spend the time trying to multiply all these numbers out to find, let's say, for example, the 17th term. You know, we don't want to do that. That's a lot of work. So what we're going to do instead is we are going to use our formula. Okay, so the formula that we have for geometric sequence is a sub n is equal to a sub 1 times, so sorry, I wrote the wrong, times r raised to the n minus 1. Okay, now we use the same formula. The formula we actually did was in function notation before. So f of n is equal to f of 1 times r raised to the n minus 1. Okay, so same as before when we talked about arithmetic sequence. These are just two different ways. Sorry about that announcement. So there's two different ways to write this. We can write it, in terms of a sequence, or we can write it in terms of a function. So either way, it's correct. The only difference is just which way you're most comfortable with. So this is always going to be your y value, a sub n or f of n. And then a sub 1 is the same thing as the first term that we talked about before. Okay, it is the first term, whether you write it as f of 1 or a sub 1, either way. And then r, of course, is the common ratio. Okay, and everything else is the same in the formula. Okay, it's just a different way of writing it if that's something that you feel more comfortable with. Okay, so we are going to pause right there, and in the next video I will go through a few more examples of these and then finish up your notes.